Hello, students. Mr. Hausnack back for the second screencast in our series of three to review topics in the forces of motion unit. So let's get to our notes. Some things I already have filled in here. This is just kind of an overview of different types of forces. Just remember, a force is a push or pull, has strength and direction. Force is measured in newtons, represented with a capital N. Then we have a number of different types of forces. Some of these we'll talk about in more detail than others. Of course, we have magnetic force, electrical force, of course, gravity. Can't certainly forget about gravity and its influence on us, as well as friction and buoyancy. When we get into friction, we know that friction is a force that opposes motion. So you see the stroller has a motion to the right. Friction is moving in the opposite direction to the left. In order to move, an object has to overcome the force of friction in order to go in motion. But friction causes moving objects to slow down and to stop moving. And friction really is exerted by a surface or a series of surfaces that come into contact with one another, such as between this surface and the wheels on the stroller. The force of friction exerted by a surface depends on the texture of the surface. So a smooth surface will exert less friction than a rough surface. When we talk about friction specifically as it relates to fluid, we refer to that as drag. So you may have heard of planes that experience drag as they're flying through the air. This particular table I'll let you read over. This just shows you different ways that we can increase and decrease friction depending on the situation that we find ourselves in. Moving on to gravity. Gravity, obviously a force of attraction between two objects. The more mass of the object, the more gravity is exerted by the object. As far as the strength of gravity, gravity does decrease when the distance between objects increases. Then the key thing about gravity is we've got to make sure we understand the difference between mass and weight. The amount of matter in a given object is mass. And remember, mass does not change. That remains constant. What does change, though, is your weight, depending on where you are. So if you are here on Earth, you're going to weigh more than you would if you go further away from Earth to something that has less gravity, which would be the moon. So you would actually weigh less on the moon than you do here on Earth, but your mass will remain the same because that is always constant. A little bit later on, we'll get into calculating weight when we get into Newton's second law of motion, and we'll use this formula F equals ma. Okay, moving on to buoyancy. Buoyancy is a contact force exerted on an object in a fluid, usually water. Depends on certainly the density of the fluid and how much fluid is displaced by the immersed object. When we talk about really buoyancy, we're talking about whether something's going to sink or float. If the buoyant force is greater than or equal to the weight of the immersed object, the object will float. If the buoyant force is less than the weight of the immersed object, the object will sink. Okay. Now we can go through a series of different types of forces here. Applied forces, usually the push or a pull. We have normal force, and that's the support force that keeps this book from falling through the table. Of course, we have friction, 4 different types, which we'll get into a little later. We have tension force, transmitted through a string rope. If you remember the Winter Olympics, there was quite a bit of force in that rope, therefore it broke. We have spring force, the force in the spring when it's compressed wants to push outwards. When the spring is stretched, the spring wants to pull inwards. Then we get certainly to gravitational force. We'll look at that next week. And finally, when we look at balanced forces and unbalanced forces, when these forces usually come in pairs, these forces have a strength and a direction. And when we see here, we have 2 different forces, one to the right, one to the left, each having an equal amount of force. So when we actually look at what we call net force, that's the combined result of all forces acting on the object. So 5 to the right, 5 to the left, we actually have a net force of 0 newtons here. So this would be a balanced force. Now, when they are not equal, then we would refer to that as being unbalanced. When we get to the next slide here, when an object is in motion, it's going to remain in motion, and an object at rest is going to remain at rest unless it's acted on by an unbalanced force. So you can see an example of a balanced force here and an unbalanced force here. Okay, so that will conclude the second segment on types of forces. Stay tuned for segment 3 on free body diagrams in just a little bit.